All right, welcome. Today, we're going to take a guided tour through one of the most game-changing pieces of cloud tech out there, AWS Lambda. And the goal here is pretty simple. We're going to demystify how it really works from the inside out so you can go build better, faster serverless applications. But before we dive in, I want you to just chew on this question for a second. What if you could just write your code, push it out there, and have it run, scale, and handle everything without ever thinking about patching, provisioning, or managing a server again? I mean, that's the whole promise of serverless, and Lambda is right at the heart of it. Okay, let's get into it. Our first stop on a tour is to get a handle on what AWS Lambda even is at its core. And, putting it simply, it's a service that lets you run your code in response to, well, pretty much anything without you having to worry about the computers underneath. Now, your code doesn't just run out in the ether. It runs inside something called an execution environment. The best way to think about this is like a clean, super secure, and totally isolated little sandbox that gets spun up just for your function to do its job. And the tech that makes all this possible is called Firecracker. This is a custom-built piece of magic from AWS that launches these tiny, secure microVMs in a fraction of a second. And this isn't just a minor detail, it's the absolute core innovation that gives Lambda its incredible speed and that hardware-level security. So now that we know where the code runs, let's go a level deeper. Our next stop takes us inside that execution environment to really understand its life cycle. How does a function actually come to life, do its work, and then, poof, disappear? It all boils down to three distinct phases. First up is init. This is where AWS grabs your code, sets up the language runtime, and gets everything ready. Then comes invoke, which is the main event. Your code actually runs. And finally, shutdown, where the environment gets frozen and eventually tossed out if it isn't needed anymore. So listen up, because this is crucial. That very first phase, the init phase, that's the source of the infamous cold start that you hear so much about. If your initialization code is slow, that very first request is going to feel it. And this is a fundamental concept that every single Lambda developer has to wrap their head around. Now, inside your code, you're mainly dealing with two key things. First, there's the event object. That's the what. It's the data telling your function what to do. Think of it like a memo saying, hey, a new image was just uploaded to this S3 bucket. Then you have the context object. That's the how. It gives you info about the runtime itself, like how much time you have left for a timeout. Your main function, called the handler, uses both of these to do its work. Okay, so we know how a function lives and breathes, but what kicks it off in the first place? Let's look at the three main ways Lambda listens for something to do. And this table here lays it out perfectly. First, you've got synchronous calls. Think of an API call for a user login. The caller makes a request, and it waits right there for an answer. Then you have asynchronous. This is like fire and forget. The event gets dropped in a queue, which is perfect for background jobs like processing a video you just uploaded. And finally, there's polling, where Lambda itself is the one doing the work, constantly checking a source like a queue or a database stream for new stuff to process. That async model brings up a really important question, right? If the caller isn't waiting around for a response, what happens if the function fails? Does that work just get lost forever? Thankfully, no. Lambda has you covered with a built-in safety net. By default, it will automatically retry a failed async job 2 more times. And if it still fails after all that, the event gets sent to what's called a dead letter queue, or a DLQ, so you can go investigate what went wrong later. Okay, let's shift gears. We've got the fundamentals down. Now it's time to pop the hood and learn how to tune this engine. This next part of our tour is all about mastering the speed and scale of your functions. So you've got 2 main levers to pull to control scale. Reserved concurrency is your safety valve. It sets a hard limit on how many functions can run at the same time. This is absolutely crucial for protecting something like a database from getting slammed with too many connections. On the flip side, provision concurrency is your accelerator. It keeps a certain number of environments pre-warmed and ready to go for those apps where every single millisecond of latency counts. And here is a massive pro tip that ties right back into that lifecycle we talked about. Any heavy lifting, like setting up a database connection or initializing an SDK, you should always do it outside of your main handler function. Why? Because that code only runs once during that init phase. The connection then gets reused over and over for subsequent invocations, saving you from that slow startup penalty every single time. It's a huge win. Now, I want you to just look at this number for a second. 1,792 megabytes. I know, it seems totally random, but in the world of Lambda performance, trust me, this is a magic number. And that's because it's the precise amount of memory you need to give your function to guarantee it gets access to one full virtual CPU core. If you allocate less than this, you get a fraction of a core. If you allocate more, you get more than one. Which brings us to what might be the single most important lesson for tuning Lambda. In this world, memory is the master dial. You don't get to control CPU directly, you don't control the network, you control the memory, and everything else scales up right along with it. In fact, sometimes giving a function more memory can actually make it cheaper because a CPU-heavy job will finish so much faster. All right, for our final stop on the tour, let's talk about the front door. How do you actually expose your Lambda function to the big, wide internet? Well, you've really got two main choices. On one hand, you've got function URLs. They're simple, they're basically free, and they have a nice, long 15-minute timeout. On the other hand, you have API Gateway. This is a full-blown, powerful service with all the bells and whistles. Advanced authentication with things like Cognito, custom routing, you name it. But all that power comes with its own price tag and a much shorter timeout. So this leads to the question I get all the time. Can I just use that simple, free function URL for my production app? And the honest answer is, it depends. But for most serious production applications that need advanced features like custom domains, complex routing, or protections like rate limiting, API Gateway is almost always going to be the safer, more robust bet. So as we pull back into the station here, let's quickly recap the highlights. Remember, that init phase is what causes cold starts. Memory is your master dial for performance, reserved concurrency is your safety brake to protect your other systems, and API Gateway is your feature-packed front door for real-world production APIs. We've looked at the environment, the lifecycle, the triggers, the performance levers. You now have a real map of how AWS Lambda works under the hood. So the final question isn't about what Lambda is anymore. The question is for you. Now that you know which levers to pull, how are you going to build your next serverless application?